Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 1 from Module 2, Distributions and Their Shapes. So classwork, statistics is all about data. Without data to talk about, or to analyze, or to question, statistics would not exist. There's a story to be uncovered behind all data. A story that has characters, plots, and problems. The questions or problems addressed by the data and their story can be disappointing, exciting, or just plain ordinary. This module is about stories that begin with data. Example, graphs. Data are often summarized by graphs. The graphs are the first indicator of variability in the data. A dot plot is a plot of each data value on a scale or number line. So this is review because I know you've done this in prior math classes. This is a dot plot of viewer age. So maybe they're talking about a TV show and they want to know how old people are that watch this show. Well, it shows that 3 10-year-olds, 1 8-year-old, 1 7-year-old, 1 6-year-old. You get the idea? 39-year-old, a 39-year-old, 41-year-old, 2 42-year-olds. And the most popular age to watch this certain show is 1, 2, 3, 4, 5, 6, 7, 8 71-year-olds watch this. Okay, so it's a TV show that seems to interest older people and younger people at the same time. But they kind of lose people between the age of 28 and 40. Okay, so that kind of information is what we can gather from graphs. The next kind of graph is a histogram. It is a graph of data that groups the data based on individuals and represents the data in each interval by bars. Now the difference between a histogram and a bar graph is a histogram does not have any space between two bars that are next to each other, where a bar graph can show spaces between each bar. The only time we would have a space between two bars in a histogram is if we had zero data in that range. So in this case, we're talking about percentages and age in years. The histogram of ages for Kenya. So 17% approximately, 17% of the population in Kenya are between the ages of 0 and 5. And it decreases as we go. And there is almost nobody age 85 to 90, and there's nobody over the age of 90. Okay, so as we get older, the number of people in Kenya decreases. The next graph is called a box plot or box and whisker plot. A graph that provides a picture of the data ordered and divided into 4 intervals that each contains approximately 25% of the data. So the whiskers, this is called quartile 1, right here, Q1. How about I label that as we go? We'll just review a little. This is quartile 1, and this is quartile 4. This is quartile 2 and quartile 3. Okay, that's the body. So 25%, 25%, 25%, 25%, totals of 100%. And they said approximately because this right here is considered an outlier. Okay, so not all data would be on the box or whisker. Sometimes if you have one item of data way out of the norm, then they are put as a dot or an asterisk. So 25%, this is a number of pets. Number of pets, what, in a household, I guess, maybe? So 25% of the population has between 0 and 1 pet. 25% has 1 to 2 pets. 25% has 2 to 5 pets. And 25% has 5 to 10 pets. And there's an outlier where some people have as many as 12 pets, whoever was questioned for this graph. Okay, exercises. Answer the questions that accompany each graph to begin your understanding of the story behind the data. Transportation officials collect data on flight delays. the number of minutes past the scheduled departure time that a flight takes off. Consider the dot plot of the delay times for 60 Big Air flights during December 12th. Dot plot of December delay time in minutes. So 0 means they took off on time. So 2 planes took off on time. 1 plane was about 6 minutes late leaving. 3 planes were 10 minutes late, and so on and so on. And there were 2 planes that were 2 hours late leaving. So I just kind of want to get a feel for what this graph is showing us and then look at the questions. One says, what do you think the graph is telling us about the flight delays for these 60 flights? Okay, and what I would say there is, let me type this because it's hard to write with the pen, and start a, so what I would say is, most flights are delayed 12 or 15 minutes, or about 15, 16 minutes. And many are delayed for a longer period of time, up to 2 hours. Okay, maybe that font's a little small. Let's make that a little bit bigger. That's weird. Okay. Anyway, most flights are delayed 15 minutes, and many are delayed for a longer period of time, up to 2 hours. Number 2, can you think of a reason why the data presented by this graph provide important information? Who might be interested in this data distribution? Okay. Let me get my and let's make it red right from the start. Okay. Well, if I look at this airline and I want to fly somewhere, and I have 3 or 4 different airlines to choose from, taking off from my location, then I see a lot of planes getting delayed here. I don't like sitting in the airport longer than I have to. I like to get where I'm going. So I would say that if flights are delayed, travelers may choose a different airline. Then it says, who might be interested in this data information? I would say the airline, and they were called Big Air. Big Air and travelers using this airline. Would be interested in this information. Number 3, based on your previous work with dot plots, would you describe this dot plot as representing a symmetric or skewed data distribution? Okay, now remember, whenever we're trying to decide if something is symmetric, symmetry would show the graph going up, and it would be a normal distribution curves like so, okay, where our data increases to a certain point and then starts decreasing, and there's a line of symmetry in between. It does not look like we have that. What we have is, if we were to draw a graph, this is tapering off, this is going way off to the right, so it is skewed. Okay, so this data is skewed. And that's your explanation. You would say because a lot of data trails off, there is a tail to the right. Okay, so I will type that in. Okay. I would say the data is skewed. Because there is a tail of data to right. Okay, so the data is skewed. A random sample of 80 viewers of television show was selected. The dot plot below shows the distribution of the ages in years of these 80 viewers. So here's the dot plot of the viewer age. This is the same graph from page 1. And it says, what do you think the graph is telling us about the age of those 80? Okay, so let me switch to 11 and red. Okay, so I would say that, oh, what happened? I think I changed pages when I hit enter. Yep. Give me a second here. Okay. So I would say this, oh, that's weird. This show appeals to people between the ages of 60 and 75 with a wide range of viewers. Okay, all the way down to 6 years old, something like that. But it appeals more to the 70-year-olds here because of this spike right here. Can you think of a reason why the data presented by this graph would provide important information? Okay. The reason for that would be if you are a TV show or let's say you're a channel, a network like ABC, NBC, CBS, something like that, you would be interested in this information. So the data would be important to determine audiences. Okay, so you want to know who's interested in the show. Who would be interested in this? Well, networks want you to watch their channel, obviously. And if you're advertising on that show, then people who sponsor the show, advertisers. Okay, so advertisers and networks would be interested. Number 6, based on your previous work with dot plots, would you describe the dot plot represented as symmetric or skewed? Okay, again, if I were to draw a trend line here, it's kind of trailing off over here, then it curves up, and then it goes down like that. So I would say that is skewed. It has a tail to the left. Okay, so it is skewed. It has a tail to the left. Okay. The following histogram represents the age distribution of the population of Kenya in 2010. What would you think this graph is telling us about the population of Kenya? I would say the population of Kenya is mostly age less than 10. Okay, something like that. 17 and 15 is a total of 32. 32% of the population is under 10 years old. That's almost a third of the population are under the age of 10. Why might we want to study the data represented by this graph? Okay. Okay, so the reason for this data being helpful in this situation would be life expectancy. What just happened? Okay, so why might we want to study the data represented by this graph? Okay, it seems that the population is young, meaning people don't live long. Finding out why could fix the issue and allow people to live longer. Okay? Number 9 says, based on your previous work with histograms, would you describe this histogram represented as symmetric or skewed distribution? Okay, so again, this is curving down like so, and it just peaks right there. So that is skewed, and it has a tail to the right. I'm not going to write it again, but it's skewed because there's a tail to the right. So it is skewed. Okay. Okay, the following histogram represents the age distribution of the population of the United States. Okay, so looking at this graph, it is fairly steady. The percent of the age distribution in years between the ages of 0 and 5 is about 6.5%. 5 to 10 is about 6.5%, and maybe a little more. 15 to 20 age, 15 to 20 is still around 5.6 or 6.6%. 20-year-olds is 7%. 20 to 25 is around 7%. And it seems like it's pretty consistent between 6.5 and 7 and a little more than 7% all the way until we get to the age of 55. Then from the age of 55 down to 100, 105, it starts to decrease. What do you think the graph is telling us about the population of the United States? I would say the percentage of the population is about the same in each interval until around age 60. Then it decreases. Okay. I'm just going to do this real quickly, so it'll just be easier for me to change instead of changing everything. Why might we want to study the data represented by this graph? Let's see. Population data determines many things. Health care, education, insurance, Okay, if I'm an insurance company, what are my risks of selling someone life insurance if they're 70 years old? What is their life expectancy once they're at that age? How much should I charge them so I don't lose money if they pass away? That kind of thing. So there's a lot of information coming from population age. All right, next problem. 30 students from River City High School were asked how many pets they owned. The following box plot was prepared for their answers. What does the box plot tell us about the number of pets owned by the 30 students at River City High? Okay, I'm just going to copy over my answer from before just so I can change it easily. Okay. So what I would say was half or 50% of the population of this school has between 1 and 5 pets. Okay? So 50% is the box portion. And I know this was in 6th grade. That was 3 years ago. That is called the interquartile range. The distance or the range from this end of the box to this. So 5 minus 1 is 4. The interquartile range in this case would be 4. Number 13. Why might understanding the data behind this graph be important? Okay. Well, there's many reasons. It depends on who's doing the study. What if you were a pet food company? You'd want to know how many people own pets. We might want to have a puppy play day, and we want to know how many people have dogs or pets. We might want to have, if this, this is a high school, so it wouldn't be show and tell, that'd be more elementary school. But you get the idea. There's certain things that involve animals, and you want to ask questions about the population. Okay, 22 juniors from River City High School participated in a walkathon to raise money for the school band. The following box plot was constructed using the number of miles walked by each 22 juniors. So there are 22 juniors, and right here is the minimum. So the one person only walked about a mile. And then 25% walked 1 to 4 miles. So this was 25%. So 25% of the students, a quarter of how many? 22? Well, a quarter of 20 is 5. So about 5 or 6 students walked 1 to 4 miles. 25% walked 4 to 8 miles. So that'd be another 5 or 6. Another 5 or 6 walked between 8.5 miles and 9. And another 25%, 5 or 6 people, walked between 9 and, say, 11 miles. Okay? So half of the juniors walked between 4 and 9 miles. Okay? And I'm not going to write this all down, but I already said it. 25% walk between 1 and 4 miles, and 25% walk between 9 and 11 miles. 15 says, why might understanding the data behind this graph be important? Let's see. They provide an indication. Whoops. What's going on there? They provide an indication of the participation of the junior class. who may be important, who may be interested in the data, sponsors of the event may be interested in this. Okay. If students aren't going to participate, then a sponsor may not be interested in spending time and money on this event. Okay, that is the end of lesson 1. Review the lesson summary and go do your problem set.